Alright, so it says in 1 minute a fly travels at a constant rate from the point -201 to 4825. And it wants to know what the vector is of the fly after 1 minute. So what you need to find is the distance between the x's, the y's, and the z's. So you take from -2 to 4, equals 6. So that's like the distance. Yes, Maggie?
Wait, what's the difference between a displacement vector and like a real vector, like a normal vector?
Like it's
Isn't it
just like
the
trying
same
to
thing?
find like the difference, like the
So it's
distance.
just a vector?
Displacement vector is vector that goes, it's like,
So it's the same thing as like,
No.
okay.
Alright, and the next one is 0 to 8. And that's going to equal 8. And then 1 to 25. And that equals 24. Yeah. And so, you know that the vector is going to be 6, 8, 24.
I got it right, guys.
That is the question.
Yep.
I told you I
All right, your original vector for 1 minute was 6, 8, 24. That's your 1 minute vector. So now you want to figure out how far it is in 2 minutes. So we'll multiply that by 2 for our 2 minute vector of 12, 16, 48. That's our 2 minute vector. Now to find how far he travels, okay, that would be the magnitude of the vector. And to find the magnitude of the vector, because he's going 12 in one direction, in the x direction, 16 in the y direction, and 48 in the z direction, we can use a three-dimensional Pythagorean theorem with just these components. So all you would have to do is go...
A squared plus b squared plus c squared equals d squared.
Yes, Mason. So it'd be a squared plus b squared plus c squared equals d squared. D being the length, how far he is. So we can put it all together into one simplification here. D equals the square root of 12 squared plus 16 squared plus 48 squared
just to find the distance.
to find that distance. And when you do the simplification there, I believe you get the square root of 2704, which is 52.
So Mason was right. So that's the distance.
Here we have that we were trying to find out a vector component form. So
Not that one.
that's this form on the board here. So if I want to have vector component form, we're going to go x, y, and z, because we're in 3 dimensions, equals, now our starting point is -2, 0, 1, so -2, 0, 1. And then we're going to add our vector, 1 minute vector, so it'll be t, and that was 6, 8, 24. And that is our vector component form.